Hello students, today we will talk about other system of nomenclature part 2. So in the previous session or in the previous video we discussed about the other system of nomenclature in Fisher configuration or Fisher projection you can say. We started with that. So today we will take some examples or some more examples about that sugar molecule so that we can get the idea about how we can assign the configuration in all the chiral carbon, especially in sugar molecule. So today we will take the glucose structure also, and we will try to assign the configuration or RS configuration in structure of glucose. So we will take the D-glucose. Before that, let's have the examples of compound having only one chiral center, just as a beginning. Okay, so this was the sequence rule we have already discussed. First rule, highest atomic number will get the priority first. When the priority is not decided by first atom attached, then proceed with comparing next atom further attached. The third one, if double bond or triple bond are present at a group, we have to duplicate or triplicate it. Now we'll start with an example. So let's talk about this example. So here I will take an example of amino acid which is having the structure like this. Here it is CH3 NH2 OH. Here it is having COOH. Okay, so that will be the amino acid as the amine group, as this molecule having amino as well as carboxylic group. So CH3 NH2 COOH. Let's consider here is the hydrogen. So this would be the structure of amino acid, that is alanine. Okay. If this methyl group replaced by hydrogen, that would be glycine, and glycine doesn't have chiral center because to be a compound, a chiral, it must have four different groups. So in case of glycine, if we put hydrogen, in case of glycine, it will have the hydrogen here. So see, one hydrogen, two hydrogen. This is the carbon which will have two similar atom or group there. So it will not be a chiral amino acid. Okay. So this is the structure of alanine. Now by applying those rules, we will see whether it is R or S. So what I told, we will give the priority as per the atomic number. Here carbon, here hydrogen, here nitrogen. Whenever it is having the hydrogen, give it 4. Nitrogen will get priority over the carbon, so it will get 1. Carbon, carbon. So see, this is the carbon. Now here rule number 2 will be applicable. Carbon and carbon. So now what we will have to do, we will have to see the next directly attached atom with this carbon. Here three hydrogens are attached. Here carbon attached with the oxygen. So in comparison of hydrogen, this oxygen having the atomic number 8, here hydrogen. So hydrogen having the atomic number 1. So definitely because of that oxygen, this will get the priority. So 1, 2 and this will get the 3. So now we will have to move 1 to 2, 2 to 3, right? So it is anti-clockwise. So this is the structure of alanine, and the carbon, the configuration of this carbon would be S in case of this structure. What I told, the least priority group must be in vertical line. If it is not, if it is in horizontal line, so what we will have to do? We will have to revert it. So this is the structure. We will have to revert the stereochemistry because here the hydrogen is in horizontal. So we will revert it. Now it is the structure of alanine. The configuration of that carbon in alanine, which is a chiral carbon, will be R. Okay, so I hope now it is clear. We'll talk about another molecule. In the previous session, we discussed about the L-erythrose and D-erythrose. Okay, so now today we will take an example having two chiral center, that is threose. So we will draw the structure of D-Threose. So let's take the threose. This is the structure of D-Threose having aldehyde. Here definitely it will have CH2OH. OH here, H here. Why it is D? Because in this structure the hydroxy group in the first chiral carbon from the bottom, it is attached to the right hand side. So this would be the D-Threose. Now carbon number 1, 2, 3, 4. Total number of carbon are 4 there, but only 2 chiral carbons are there because as you can see, this is these two are the carbon having different atom. Okay, so this is the chiral number 1. So we will talk about that. Then we will talk about chiral carbon number 2 or carbon number 3. So chiral carbon or chiral center 1, chiral center 2. See what we will do. First, we will have to identify the 4 different group. So what is that 4 different group here? Let me show you. Group 1, group 2, group 3, and this will be the complete group 4. Okay. So now we got the 4 group. We have to assign the priority according to the atomic number. This is the chiral carbon. From this, oxygen is attached. Here, hydrogen. Here carbon, here carbon. So as per the atomic number, this will get priority. Hydrogen you are getting 4. Out of these 2, we will have to set, we will have to assign the priority. So now what we will do here, we will try to rearrange that. How? See, C double bond O aldehyde is written like that. I told you if it is having the double bond, so you will have to consider it like this. Oxygen is bonded with 2 single bonds with carbon and the hydrogen. Okay, I'm talking about this. What about here? This is the center of 2. Now this whole group I will draw here as the carbon number 3. So this is the 3, carbon number 3. This OH, H. Carbon number 4 having H, H, OH. We have to find out the point of difference. Okay, so the carbon number 4, carbon number 3, carbon number 1, and this is the point of what we are talking about. Okay, now we have to compare. As the rule number 2 said, if two similar atoms are attached, carbon here, carbon here, we have to move the next one. So let me show you this carbon having carbon bonded with oxygen. This is also having the carbon bonded with oxygen. No point of difference. This carbon bonded with carbon. Okay. This carbon bonded with oxygen. This carbon bonded with hydrogen here. This carbon bonded with hydrogen here. So have you seen the point of difference? This is the point of difference. Point of difference. Carbon bonded with the carbon here. Carbon bonded with the oxygen here. Okay. This was the similar. Carbon bonded with oxygen. Carbon bonded with oxygen. Carbon bonded with hydrogen. Carbon bonded with hydrogen. But the difference is carbon bonded with oxygen here. Carbon bonded with carbon here. So carbon having the atomic number 6. Carbon having atomic number. And oxygen having atomic number 8. So out of these two groups, this will get the priority. So one priority already has been assigned. 4 is also. So now 2 and 3. So this will be the 2. This will be the 3. Now what to do? We have to move 1 to 2, 2 to 3. So how it is moving? Clockwise direction. It is a clockwise direction. But see the fourth group. How it is? The fourth group is in horizontal. As per the rule, it must be in vertical line. So what we will have to do? We will have to now C2 configuration around the C2. It is clockwise. It should be R, but now because the least priority group, it is in horizontal. So we will have to revert it. So it would be S. Okay. So now the configuration around this carbon is S. Now we will talk about the configuration around 3, carbon number 3. So for that, let me draw the first we have to find the 4 different groups. So what are those 4 different groups? Let me show you. We'll see what is that 4 different group. Okay. This is the carbon. Now we will talk about this. C2 already we got C3. So here I will go C3. This is the C3. Here 4 group. So CS2, OH, OH and H here. Now this complete will be another group, means fourth group. So here we can write it C H O H, C O O H. Okay. Now let me open this also, so it will be easier. See, we can write it like H H O H. Now what? This is the center of carbon number 3. 1, 2, 3. So we have to assign the configuration of that. So group, 4 different groups we have identified. So let me show you the 4 different groups. This is the group 1, group 2, group 3. This whole will be the group 4. Right. Now assign the priority. As the carbon bonded with, there is a carbon. This carbon is bonded with oxygen. Oxygen having atomic number 8 will get priority 1. As I told you, whenever you see the hydrogen, give it 4. Now, out of this and this, which will get priority? Here is a carbon, here is a carbon. Now, what we will have to do? We will have to see the next one. So, as you can see, this is the group having hydrogen. Is it common here? Yeah, carbon and hydrogen also present here. What about this? Carbon, hydrogen, carbon, oxygen. Okay, so this carbon oxygen you can say it is a common here. Carbon oxygen. Okay, we have to see that whether it is having the common or not. So C double bond O is common here. C double bond O is common here. Means the carbon is bonded with oxygen here with the next atom, and here also carbon is bonded with the oxygen in the next here. Okay, it may be like vertically or horizontally arranged. Now the next difference. See, this is not a difference. Here also we got the CO. Here also we got the C single bond O. C hydrogen. C means carbon single bonded hydrogen. Now the difference here we have carbon hydrogen. What is here? Carbon bonded with carbon. So this is the point of difference. So carbon having atomic number 6, hydrogen atomic number 1. So out of these two, this group and this group, this will get the priority because we got the point of difference here because it is having the next group attached with the carbon. Now we have assigned 1, 4. This will be the 2. Means this is the carbon. Will be get 2 and this will be 3. We have to move 1 to 2, 2 to 3. Anticlockwise, as it is anticlockwise, C3 will be S, but see the hydrogen. How hydrogen is attached? It lies in horizontal plane or horizontally that attached. The fourth group, least priority group, it must be in vertically. So if it is in horizontal, we will have to revert it. So what it will be? It will be R. So you can say in triose structure, the carbon number 2 and 3 configuration is S and R. Now you can assign the configuration in this manner to any compound. Okay, so now I hope it is clear that how to assign. Okay, see this. This is the D-Threose. What could be the configuration of L-Threose? Can you tell? Because this would be the mirror image of that. So the mirror image of this D-Threose, if we will draw, we will get the structure like that. The mirror image, I cannot draw here because already it is written there. So the mirror image of this molecule will be H, OH, here, OH, H, CH2, OH, CH4. This would be the mirror image of this structure, D-Threose. So this is L-Threose. So obviously this is the mirror image. So the configuration is here C2R, C2S, C3R. Here you can try, and after the assigning the rule or applying the rule, you will get that C2 will be R, C3 will be S. You try yourself, and still if you have any difficulty, you can uh, tell your query in chat box. I will definitely address the query. Okay. So I hope by applying these rules, now you all will be able to assign the configuration in any sugar molecule, whether it is having 5 chiral center, 4 chiral center, 6 chiral center. So I would like to tell you that if you try yourself to assign the configuration in glucose carbon, and if you find any difficulty, just write your question in chat box. I will definitely in the next lecture I will tell you that by taking glucose or D-glucose as an example. So how we can assign the stereochemistry or RS configuration in glucose structure. Okay, so I hope you are also enjoying the learning with PChem Easy by Dr.